Welcome back. We are on doing our ECT Prep Unit 4, Intermediate Algebra Topics, and this is a cumulative ACT practice over your Intermediate Algebra unit. So, go ahead, try this one, hit pause, come back when you're ready. And hopefully you got 1/9. Alright, so if you remember our drop the bars, drop the inequality, keep the sign the same, drop the bars, flip the inequality, change the sign on the other side. So if I solve each of these, alright, add 5, I get 9x less than or equal to 9. Divide by 9, I get x is less than or equal to 1. If I graph that, it's a closed circle to the left. Solving the other one, I'm going to add 5, I get 9x is greater than or equal to 1. Divide by 9, and x is greater than or equal to 1/9. So 1/9 is smaller than 1, so it's over here somewhere. Closed circle to the right, and this is an AND statement, so my solution is everywhere in between. Remember, if it's pointing at the bars, you're going to end up with an AND statement. If it's eating the bars, you're going to end up with an OR statement. So it says, which of the following is a solution for the inequality? So they're not asking me for the solution would be x is everything and including between 1/9 and 1. But they're just giving me choices, okay? And they want to know which one is a solution. Well, if it's in that shaded region, it's a solution. Well, 2 is over here, so it's not. -1 is down here, so it's not. 1/10 is 1/9, 1/10. 1/9 is included because of the bar. So because it is a or equal to problem, the 1/9 is included, and that's my solution. So I don't need to check the rest of them if I don't want to. Alright, and again, you can do it on the calculator, but like I said, I think it's a lot more work to do it on the calculator than it is just to do it by hand. Alright, try this one, hit pause, come back when you're ready. Alright, it says given the two linear equations, what is the sum of the x and y values that will make both equations true? So they want me to solve it for x and y, and then they want me to add them up. Well, anytime they give me two equations, it's a system of equations. Me personally, I like to line them up and use elimination. So I'm going to eliminate the y's. If I'm going to eliminate the y's, then 4 goes up, positive 4 goes up, positive 3 comes down. Alright, but since the signs came out the same, I need to make them different. So I'm going to make this bottom negative instead of positive. So then when I distribute, on top I'm going to get 20x plus 12y equals 8. And on bottom, I'm going to get a negative 18x, a negative 12y, and a negative 27. And my y's will be eliminated, which is what I wanted. So I have 20x take away 18x, which is 2x, equals 8 take away 27 is negative 19. Divide by 2, and I get x equals negative 19/2. Okay? There's x. Now I got to find y, so I'm going to go plug this back in, and I plugged it into the bottom equation, which says 6 times your x plus 4y equals 9. Plug it in, negative 19/2, and solve it. If you distribute the 6 just to the top, not the top and the bottom, that's going to be negative 114 over 2 plus 4y equals 9. Now, you can kill the fraction Oh, well, actually, you can just divide. Okay, it comes out even. This comes out to negative 57 plus 4y equals 9. So add 57, add 57. I get 4y equals 66. Divide by 4 and reduce y equals 33 halves. Okay, so what I'm supposed to do then is there's my x and there's my y, and they want me to add them up. So if I take negative 19 over 2 plus 33 over 2, I end up with 14 over 2, which is 7. Okay? And like I said, there's your solutions. Add them. There's 7. I put the calculator stuff on there just in case those of you out there that are just calculator freaks and love to do everything on it. You can, but I still think by hand is faster. Alright, try this one. Hit pause. Come back when you're ready. And hopefully you got C. Alright, order of operations. They want me to add, but they also want me to multiply that first one by negative 4. Well, just like PEMDAS and everything else, we follow PEMDAS with matrices. I have to multiply first. So distributing the negative 4 to every element, I get negative 16, positive 8, negative 28, negative 12. And now I can add that to the second matrix because the dimensions are the same. So when we add corresponding elements, I'm going to get negative 16 plus a negative 3, 8 plus 2, negative 28 plus 2, and negative 12 plus 5. Which gives me negative 19, negative 26, positive 10, and negative 7. Okay? Hit pause, come back when you're ready. And hopefully you got J. It says quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Plugging my ABC in, b is negative 2, a is 1, and c is 5. Okay, so typing in underneath, right, I get x equals 2 plus or minus the square root of negative 16 all over 2. Well, that negative under there comes out as I. And then the square root of 16 is 4. So I have 2 plus or minus 4i all over 2. And then the 2, 2, and 4 can all be reduced by 2. 2 goes into 2 once, 2 goes into 4 twice, 2 goes into 2 once. So my final answer is 1 plus or minus 2i. And they write it out as 2 separate ones. Okay? Alright, try this one. Hit pause. Come back when you're ready. Hopefully you got E. Alright, drop the bars. Drop the inequality. Keep the sign the same. Drop the bars. Flip the inequality. And change the sign on the other side. Solving them both. I'm going to minus 4, I get x is greater than or equal to 6. So 6 gets an open circle to the right. So closed circle to the right. To solve the blue one, I'm going to minus 4, I get x is less than or equal to negative 14. So negative 14 gets a closed circle and to the left for less than. So my solutions are here and here. And this one wants to know which value is part of the solution. So I'm looking for the number that falls in the shaded region somewhere. Well, negative 13 is not. Negative 5 is not. 0 is not. 5 is not. 13 is in the shaded region, so it is. Okay. Again, calculator, but Yeah, I think it's easier by hand. Okay, try this one. Hit pause. Come back when you're ready. Alright, so it says, which of the following is not a solution to the inequality? Well, to figure out what isn't a solution, I need to figure out what is a solution. If I go ahead and factor out a 2, that's going to leave x squared plus 3x minus 10 less than or equal to 0. Now a is 1, it should be an easy factor. X and x make x squared. 2 and 5 multiply make 10, subtract make 3. C is negative, which means these guys have to have opposite signs, so bully takes the middle, and he's the opposite. Which then, if I set it to 0, I get my factors. 2 equals 0, which is just silly. That's not got a variable in it, so it's not going to generate a solution. X minus 2 equals 0. X plus 5 equals 0. That gives me x equals 2. This gives me x equals negative 5. Right? So I've got 2, I got a negative 5, and I got a positive 2. And remember here, we're going to have to test the number line to see which one is true, right? So I'm going to test 0 in the middle. So I'd have 2 times 0 minus 2 times 0 plus 5. Well, that's a positive. That's a negative. That's a positive. Altogether is going to be a negative, which is less than or equal to 0. So in between is true. Now I want to know the one that is not in that green area. Well, negative 4 is, negative 1 is, positive 1 is, 4 is not. So it's not part of the solution. Okay? Alright. Try this one, hit pause, come back when you're ready. And hopefully you got 21. One morning, Pat looked at her rose bushes and saw 3 roses. The second morning, Pat saw 5. The third morning, she saw 7. If this pattern continues, how many roses will Pat see on the 10th morning? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We could try and memorize that formula, okay, for sequences, or you can just continue the pattern. It's going up by 2s. So this day will be 9, then 11, then 13, then 15, then 17, then 19, then 21. On the 10th day, she should have C, 21 roses. Okay, try this one. Hit pause, come back when you're ready. This one's easy breezy. It says, what is the maximum number of roots? Anytime you have a polynomial, the maximum number of times, it doesn't mean that it will have that many solutions or roots, but it could have as many as the highest exponent in your problem. So this polynomial could have at most 5 zeros. It doesn't mean it will have 5, but it could have at most 5. Can't go over 5. Okay, try this one, hit pause, come back when you're ready. Hopefully you got C. So which choice represents the expression without radicals and negative exponents? So everybody needs to get out of the radicals and move their negative exponents. This would become x to the 8 over 4. Moving this up makes it x to the first. Minus 1 is fine. Moving that up makes it 3x squared. Well, that answer isn't there. Well, this is x squared, right? Minus x minus 1 plus 3x squared. I can combine like terms. 3x squared plus 1x squared is 4x squared minus x minus 1. Okay? Alright, try this one. Hit pause. Come back when you're ready. Hopefully 1991. Okay, a chair manufacturer began to make kitchen chairs and rocking chairs in 1990. The function k of x, which I'm going to use y, equals 3000x plus 3800 represents the number of kitchen chairs, these are kitchen chairs, made X years after 1990, which means X stands for, if X is 5, I'm talking about 1995. Okay? The function r of x, and again, instead of r of x, I'm just going to use y, equals 3,500x plus 3,300. That represents the number of rocking chairs made X years after 1990. In what year did the chair manufacturer make the same number of kitchen chairs as rocking chairs? Anytime they give you two equations and you're trying to figure out when are they both solved, they're telling you to solve a system. This one I'm going to do substitution on because I have two letters already alone. So I'm going to pick this guy up and move him over here to this y. So I'd have 3,500x plus 3,300 equals 3,000x plus 3,800. Okay, so now let's clean it up. I'm going to minus 3,000, oops, not over there. That's going to give me, oh yeah, I'm doing great. Oh my goodness. Yes, subtract 3,000x, that leaves me 500x plus 3,300 equals 3,800. Subtract 3,300, I get 500x equals 500. Divide by 500, and x equals 1. Now, they just said in what year, so finding x, you could find y, you could go here and plug it back in and figure out your y, but I don't have to do that because they're not asking me for y. They just want to know how many years after 1991 were these manufacturers manufacturing the same amount. Well, this says 1. So how did they go from 1 to 1991? Because remember, X didn't stand for what year it is. It stood for the number of years after 1990. Well, 1 year after 1990 would be 1991. Okay? Alrighty, and we are done. So I will see you next time. Happy ACT studying.